right. Huh? You're supposed to do 28. 1 through 28. 1 through 26. All right, number 24, I wanted to go over. I wanted to go over this one because some of the strategies that we have didn't really work for this one. So for instance, I would typically say that if you had two terms, you should get a common denominator and put them together. And that strategy doesn't work very well in this problem. So that's part of why I wanted to go over this one, just so you guys could see how to work this one out if you got stuck. So for this particular problem, we're clearly working with the left side because it is definitely more complicated. So we're going to simplify that side. If you look at the right side, you can see that the right side only has a cos in it. And so that gives me a clue that on the left side, the sine squared is the thing that needs to be changed because it's not the same term as the right side. So first thing I did is I took the sine squared and I replaced it with something. Anyone know what I would have replaced it with? Not cos squared, but you're close. 1 minus cos squared, good. So now the entire problem is in terms of cos, which is good. And then this part needs to be simplified a little bit more, and you can actually factor it because the top is difference of squares. So if you look at the top, that would be 1 plus cos, 1 minus cos. And then once you have the top part factored, what happens? Yeah, the 1 minus cos completely cancels. So we are left with 1 minus the parentheses equals negative cos. And then what should I do after that? Yeah, distribute that negative. So I've got 1 minus 1 minus cos theta. And the 1's cancel each other out to make 0. 1 minus 1 is 0. And so I have negative cos theta equals negative cos theta, and I'm done. So I wanted to go over that one just because if you didn't see it that way, then you probably would have gotten frustrated and not gotten very far. All right. And we're going to go ahead and also look at number 25. The reason I want to look at 25 is because 25 is a very common problem. So 24, not very common. I don't see those a lot. 25, very, very common. I see problems like this all the time. So you want to make sure that the way that we do number 25 makes sense. So when I gave you guys strategies on proofs, I said that putting the problem in terms of sine and cosine works about 70% of the time. So that was something that a lot of you guys go for. And what I've noticed is kind of what I expected is that some of you guys go for turning everything into sines and cosines 100% of the time. And if you do that 100% of the time, then 30% of the time you're frustrated, okay? Because it does not work 100% of the time. So you can turn this into sine and cosine to work with it, but it's not the easiest way, and you'll probably get frustrated if you do that, okay? So one of the things that I said in the proofs notes was that if the problem is in terms of tangent and cotangent, do not turn it into sine and cosine. So this is exactly the situation I was talking about. Do not turn this one into sine and cosine. It makes it difficult. So between the left side and the right side, I would say they're about the same level of difficulty. They're very similar. So we have two options. We could take the left side and turn these into cotangents, or we could take the right side and turn these into tangents. So which one would you rather work with? The right side. Okay, so let's go ahead and write the left side down and just keep it the same. And then on the right side, I'm going to say that cotangent is 1 over tan plus 1, and then 1 over tan minus 1. Now over here, I have a fraction plus 1. What do I normally say about that? If you're adding a fraction with something else out, what's the process? Say it again. We're going to use that in a second, but not yet. Common denominator. You need a common denominator. So this 1 right here needs to have the denominator of tan. So I'm going to take the 1 and I'm going to multiply it by tan over tan. And I'm going to do the same thing with the 1 on the bottom. So what happens for the top is I have 1 plus tan over that common denominator of tan. So I've got 1 plus tan over that common denominator of tan. And that represents the top of the fraction. On the bottom of the fraction, I have 1 minus tan over a common denominator of tan. All right, and then Olivia, what were you saying? Keep it, change it, flip it. So we have a fraction divided by a fraction, and when that happens, we always do keep it, change it, flip it. So I've got 1 plus tan over tan, and then I'm multiplying by tan over 1 minus tan. And what happens? Yeah, the single tans, these ones cancel, right? And so we're left with 1 plus tan over 1 minus tan, and that is identical to the left side. So you'll see this particular problem. It could be tangent and cotangent. It could be sine and cosecant. It could be cos and secant. This particular problem is very common. Okay. So these ones, instead of using the everything turns into sine and cosine, this is one where you use the reciprocal for that function. So tan is the same as 1 over cotangent. Cotangent is the same as 1 over tangent, so you could do it either way. Similar process. Okay, we're going to go ahead and turn those in.